Alright guys, so for this video we're going to be talking about Oxy Mercuration Demercuration. That's another reaction that's an alkene reaction where you add an OH across a double bond. How you memorize it is that this is what we call Markov-Nikov addition. So in a double bond that's unsymmetrical, the carbon with more carbons attached to it will get the OH, and that's what you form. This is what we call an intermediate. You're adding something with mercury, and then you're demercurizing it because you turn this into an H. There should be an H right here. I just circled it for the sake of it. So an Oxy Mercuration Demercuration, I didn't draw the mechanism on this board because you don't have to know it. You just add the OH on the more substitute carbon, and it's anti-addition. So what happens is that the OH and the H after the demerc have to be anti to each other. So if one's dashed, the other has to be wedge. You always have to keep an eye out for other chiral centers on your molecule. If there's one right here, okay, this is a chiral center because there's 4 different paths. If there's a chiral center that doesn't change, that means that these are enantiomers. Well, not enantiomers, but these are switching chiral centers. You would think that they're enantiomers, but because there is that extra chiral center that's unchanged, these are diastereomers, also known as optically active, because enantiomers or acidic mixtures are not optically active. Now what you want to keep an eye on is right here. This is your nucleophile, and that's going to go attack. So instead of memorizing the mechanism, if it's H2O, you add OH. And like I said, it's anti-addition. So if this is dash, the H that was from the demercurizing step has to become wedge. Or if this is wedge, that means the H has to be dash. What if you were looking on your exam and you saw CH3OH right after the mercury compound? Well, in that case, all you have to do is scratch out the H and you go O, and this is that is not the right answer. The right answer is OME. Even I slipped up right there. OME or OCH3. So what you do is you scratch out the H and you put the O, CH3 coming off the more substitute carbon. This is the more substitute carbon double bond because there's more carbons attached to it. There's 1, 2. This has more hydrogens. This has 2 hydrogens coming off of it right here. This is 2 carbons coming off of it. So the OH, or the whatever group, if this was CH3CH2, you'd go O, CH2CH3 being added. So it's not that bad of a mechanism or kind of reaction part of me because I'm not showing you the mechanism. You just recognize that there's mercury, and in the asymmetrical double bond, the carbon with more carbons will get either the alcohol group or whatever group you have beside the mercury, and it is anti-addition. I do the squiggly line here because you could have had wedge or dash, right? Kind of how you had wedge or dash. That's like the shortcut that we use in organic chemistry. So that's Oxy Mercuration Demercuration. You're either adding an OH, the more substituted, or whatever alcohol it is.